practice doing some free body diagrams. Now in this chapter, really free body diagrams are to learn how to do them. But once we get to dynamics in 2 dimensions, you will really have a hard time solving those problems without a good free body diagram. So it's important to get the foundations of it now. In our first example, we're asked to draw a free body diagram for a flower pot falling from a windowsill. So I am not an artist. So that is my flower pot. And since this flower pot is on Earth, we know it's going to have gravity. And gravity always goes straight down towards the center of the Earth. We're going to label it F of G. And because this flower pot is falling through the air, there's air resistance on it, which is a type of friction. And friction is going to oppose the direction of the motion, so it's going to go straight up. Pretend that's a straight up line. I also want to talk about net force. Net force is always the force that's in the direction of the acceleration. And because this flower pot is falling down towards the ground, and we know that it's going to be accelerating, at least until it reaches terminal velocity, we can say the net force is downwards. So in our second example, we're asked to draw a free body diagram for a rope lifting a bucket at a constant speed. So again, there's my bucket. And we know that this bucket is on Earth. So gravity straight down. We also know that there is a rope pulling the bucket up. So be straight up, and it's called tension force. There's one more thing. This bucket is moving through the air, so there is going to be friction in the form of air resistance, and it's going to oppose the direction of motion. This bucket is being lifted, so the friction force is going to go downwards. So we're going to squeeze it in right here next to our weight, our gravity. Now for this one, we have to ask ourselves, is there a net force? And you should be able to tell, because it says the bucket is lifting at a constant speed, that there is no net force, because there is no acceleration. For our third example, we have a free body diagram for a cable pulling a crate across a horizontal surface, causing it to accelerate. So there's my crate. And you could be more creative, but it does make it a lot easier if you just make it a dot. And because my crate is on Earth, or really on any planet, there's gravity. And because my crate is resting on a surface, there's normal force, which is always perpendicular to the surface. And because this is a horizontal surface, it'll go straight up in the air. There's a cable pulling the crate, and I'm just going to have my crate be going to the right. It really doesn't matter which direction, unless I specified. So we have a tension force. Now, we also have friction force. You're going to always assume there's a friction force unless the question says ignore friction. And if the crate is being pulled to the right, then the friction force will be to the left. And our question says causing it to accelerate. So it's going to be accelerated in the direction of the tension force. So net force goes this way. Let's talk a minute about the same situation, but on an incline. So we have our same crate being pulled now on a incline, and it's accelerating. So that's my hill. It gives us a frame of reference and allows us to see how things relate a little bit better. So always draw that. And then I'm going to put my crate on it. Right there. And my crate still has gravity, and it still goes directly towards the center of the earth. So and my crate still has a normal force because it's resting on a surface. But remember, normal force is always perpendicular to the surface it's resting on. So in this situation, the normal force is going to go this way. So that it's perpendicular to this surface right here. I'm still going to have my crate being pulled to the right, though again, you can have it go any way you want. So my tension force, and I'm just making it a little bit above the line so that it's visible. And my friction force is going to oppose motion. And because it's accelerating, my net force is going to be in the same direction as the tension force. Don't worry if these are a little bit confusing now. We're going to keep practicing them, and I want you to keep trying to draw them for all the situations, even if the question doesn't ask for it.